Okay, if you are in Math 7 Excel, we're working from the Advanced 2 textbook. If you are in Math 8, we are working from the Course 3 textbook. Okay, we are doing lesson 1.1, example 1, and it can be found on page 4. 1.1, example 1, and it can be found on page 4. So this is the beginnings of algebra. And you guys have been doing algebra since 1st and 2nd grade, only you didn't realize it. In 1st and 2nd grade, you would get a problem that looks like this. 7 plus what equals 10? 3. Right. And so when you were in 1st and 2nd grade, you had 7 counters, and then you had to add counters until you had 10, and then you would know that it was 3, right? Well, let's talk about what we need to do to this problem, what's going on, so that we can apply it to more advanced problems. So in 1st and 2nd grade, this is what it looked like, and we had little teddy bear counters. Now in pre-algebra, it's going to look like this. 7 plus m equals 10. So instead of a box, we're going to use a variable, m, and this could be a, n, m, p, z. We can use any letter we want. We can use a box, we can use a picture, but typically in algebra, we stick to the letters. So what we're doing, this is what it looked like in 1st and 2nd grade. This is what it looks like in pre-algebra, and let's figure out what's going on so we can apply that to more advanced problems. The first thing we want to do is isolate the variable. That means we want to get the variable by itself. We want this m to be by itself. So if we want m to be by itself, we got to get rid of this positive 7. We got to get rid of this positive 7. So we're going to use inverse operations. What is the inverse of positive 7? Negative 7. So what I do to one side, I must do to the other. We need to keep both sides balanced. We need to keep both sides equal. So what we do to one side, we must do to the other. So these guys cancel, and I'm left with m equals, I have a positive and a negative, so I'm going to subtract. 10 minus 7 is 3. Keep the sign of the largest. M equals 3. Well, isn't that what we said up here? We already knew m equals 3, right? Well, we're using inverse operations to isolate the variable. That's what's going on. So now that we know that, we can apply that to more advanced problems. So let's go a little more advanced. This one's not too much more advanced, just a little bit. X minus 7 equals negative 6. X minus 7 equals negative 6. So the first thing I want to do is isolate my variable. I want to get x by itself. So I need to get rid of this negative 7. So what's the inverse of negative 7? Positive 7. I'm going to add 7. What I do to one side, I must do to the other. We got to keep both sides balanced. So -7 and +7 cancel each other, and I'm left with x equals, I have a negative and a positive, so I'm going to subtract. 7 minus 6 is 1, and keep the sign of the largest. X equals 1. Now, if I'm not sure, I can always check. X minus 7 equals -6. Let's substitute this +1 for x. +1 minus 7 equals -6. +1 minus 7, they're different, so I'm going to subtract. Keep the sign of the largest. That checks. Okay. So now last week, we reviewed decimals and fractions. We did that for a reason. We have y plus 3 4/10 equals 0 and 5/10. We're going to do the same exact thing. We want to isolate the variable. What is the inverse or opposite of +3 4/10? -3 4/10. What I do to one side, I must do to the other. And remember, when we're adding and subtracting decimals, we line up our place values. So +3/4 and -3/4 cancel each other. I'm left with y equals, now I have a positive and a negative here, so that means I'm going to subtract. But it's hard to subtract in this direction. So I'm going to rewrite my problem with the largest, if I take my signs away, with the largest number on top. Now I can subtract. Keep the sign of the largest number. So y equals -2 and 9/10. Okay. That's decimals. And yes, there's going to be fractions. Oh no, not the dreaded fraction. So we've got t minus 1/4 equals -3/4. Now they were kind enough to give us the same denominator. That's nice. Same rules apply. I need to isolate my variable, which means I need to get rid of this -1/4. So I'm going to add 1/4. What I do to one side, I must do to the other. So these guys cancel. And I've got t equals 3/4 plus 1/4. Remember, when we're adding and subtracting fractions, we need a common denominator. Here, they've given us a common denominator. That's very nice. So I don't have to figure out a common denominator. So my common denominator comes down. I have a positive and a negative. I'm going to subtract. So 3 minus 1 is 2. Keep the sign of the largest. T is equal to -2/4, or we can divide, reduce it, -1/2. So we are doing one-step equations. We're isolating the variable and using inverse operations to figure out what the variable is. We're using decimals, we're using fractions, we're using positives and negatives. But life doesn't stay that simple. Because the book likes to do something like this. R minus pi equals pi. Now, I've got some people that look at this and go, well, what's the variable? I have an R and a pi. Do not let this bum you out because pi is not a variable. Pi is a number. Pi is a number. So if it helps you, over pi, write 3.14. 3.14 over pi. Pi is a number. 3.14. Now, if we do that, is our variable a little more clear? Yeah. What is our variable? R. So now this is the same rules. We want to isolate the variable, get R by itself. So I need to get rid of this negative pi. How do I get rid of negative pi? Besides eating it, I'm gonna add pi. Add as in positive. What I do to one side, I must do to the other. So these pi's cancel. I'm left with R equals, now here's one pi and here's another pi. How many pi's do I have? 2. They're positive, so I'm adding. This is one pi, this is one pi. I have 2 pi's. Now, I'd like to do 2 more with you. I want to do another fraction one. I want to do another fraction example where the denominators are not the same. So we have 5/6 equals 1/3 plus D. Now, does it matter if my variable is on the left side or the right side? No, because this is the same thing as 1/3 plus D is equal to 5/6. These are the same problems. It does not matter if my variable is on the left or the right. So let's follow the same rules. We need to isolate the variable, which means I need to get rid of this positive 1/3. So I'm going to subtract 1/3. What I do to one side, I must do to the other. So positive 1/3 and negative 1/3, these guys cancel, and I'm left with D equals, but here I have 5/6 and 1/3, a positive and a negative. I cannot subtract 1/3 from 5/6. I need to find a common denominator. So remember this from last week, 5/6 minus 1/3. What's my common denominator going to be? 6. So I'm going to bring 6 out here. Now, I don't have to do anything to 6 to make it 6. So this can come straight across. But here, I'm going to have to multiply this by 2. What I do to the denominator, I must do to the numerator. And I am left with negative 2/6. So this is 5/6 minus negative 2/6. My denominator comes down. 5 minus 2 is 3. So this is 3/6. So I could leave it like this, or I can see that it is reduced to 1/2. So when you've got fractions that have different denominators, don't forget your fraction rules. You have to find a common denominator to add and subtract fractions. Okay, I've got one more example. X minus 8 pi equals pi. So remember, pi is a very specific number. And if it helps you, write 3.14 over it, because it is a very specific number. So I still want to isolate my variable. And now I need to get rid of this negative 8 pi. So I'm going to add 8 pi. What I do to one side, I must do to the other. So negative 8 pi, positive 8 pi, these guys cancel. I'm left with x equals, here's 1 pi, and here's 8 pi's, positive and positive. So I'm going to combine them. Here's 1 pi, here's 8 pi's. I now have 9 pi's. So this is what we're doing today. We are using whole numbers, fractions, and decimals. We're using positives and negatives. We are isolating the variable using inverse operations to get rid of it. And this is one of the very first steps of algebra. So make sure you understand this today, because tomorrow we're building on this. Does anybody have any questions?